We're going to look at questions that require us to do a bit more advanced interpreting of graphs of functions. So here's an example of the kind of question you can expect in a test. Look at the graphs of y is equal to minus x squared plus 1 and y is equal to x minus 1. And from looking at the pictures of the graphs, you need to be able to decide which graph belongs to which function. And so because y is equal to x minus 1 is a quadratic function, then we know it belongs with the parabola. And because y is equal to x minus 1 is linear, then we know that it belongs with the straight line. So you need to do that matching up front. Sometimes it will have been done for you, but in a case like this, you need to do that work yourself. Right, then you're asked to find the coordinates of 5 points, A, B, C, D, and E. What I like to do before I tackle questions like these is just to highlight for myself where my X and Y axes are. I get very dizzy very quickly. Right, so if we look at A is the y-intercept of my parabola. And we know that a y-intercept has coordinates 0 and something. So we're going to take 0 and we're going to make it the input for my quadratic function so that we can find the output, because that will be the y coordinate then. So we're going to say y is equal to negative 0 squared plus 1, which gives me 1. So the coordinates of A are going to be 0 and 1. That looks like a teardrop, but it's a 0. And then if we look at B is the y-intercept of my straight line. And so either you can just read straight away from your straight line's equation that the y-intercept happens at minus 1. Or again, you can say that, well, B must have an x coordinate of 0 because it's on the y-axis. And so we sub in 0 over here. When my input is 0, my output is negative 1. So either way, we arrive at the same answer of the coordinates of B being 0 and minus 1. Right, then next up, let's look at C. So C and D are the x-intercepts of our parabola. And to find x-intercepts, we use the fact that x-intercepts have coordinates something and 0, something and 0. So we're asking ourselves, for which input is my parabola going to give me an output of 0? So here's my parabola's function. And we're asking ourselves, at which point is this output going to be 0? So this is the equation that we're trying to solve. Another way you can write this is as 1 minus x squared. So just rearranging my terms so that I can see that this is in fact a difference of two squares. So this will be 1 minus x times 1 plus x is equal to 0, which means that either 1 minus x is equal to 0 or 1 plus x is equal to 0. So in this case, x would be equal to 1. And in this case, x would be equal to negative 1. So the coordinates for C would be minus 1 and 0. The coordinates of D would be positive 1 and 0. Cool. And then the last point we need to work out is E. Now, E is an interesting point. E is the point of intersection between these two graphs, the parabola and the straight line. And perhaps you will have encountered intersections last year when you studied straight line graphs. But essentially what a point of intersection is it's a place where for the same input your functions are producing the same output. So if you look at an input, if you look at an input over here, for example, the parabola is producing an output that's over there. Meanwhile, the straight line is producing an output that's over there. Or if you look at an input over here, the parabola is producing an output that's there. Meanwhile, the straight line is producing an output that's over there. But a point of intersection is special because at that point, for the same input, both functions are producing the same output. And so in order to find the point of intersection, we're asking ourselves at which point is the output of my parabola, so negative x squared plus 1, going to be equal to the output of my straight line? That's the question that we're trying to ask ourselves when we find a point of intersection. So in order to find a point of intersection, all you do really is you equate the one function to the other. That's essentially what you're doing. So you equate the output of the one function to the output of the other function, right? And this is a quadratic equation, so your strategy for solving a quadratic equation needs to kick in. Get everything on one side so that the other side is 0, factorize, use the null property. So I'm going to try and get everything onto the left-hand side. So I'm going to subtract x and add 1 and do the same here. So then I'm going to have negative x squared minus x plus 2 is equal to 0. I could then try to factorize from here, but I'm not comfortable with this negative. So the first thing I'm going to do, you could decide how you want to phrase this for yourself. You could either divide this whole thing by negative 1, but then you'd have to do it on this side as well, which doesn't really affect 0. And that would then become x squared plus x minus 2 is equal to 0. Or another way that some people might do it might be to say I'm factoring out a negative, and then they'd be left with x squared plus x minus 2 is equal to 0. So whichever way you want to do it is perfectly fine. And so now I've got a trinomial that I need to try and factorize. So we've got x, and one of the brackets must have a 2, one must have a 1, and we want a middle term of positive 1. So we're going to put the plus here, minus here. So x plus 2 is equal to 0 by the null property, or x minus 1 must be equal to 0, which means that x is either equal to negative 2 or x is equal to 1. So there are two possibilities here. I'm just going to rub some of this out. And that makes sense because there are 2 points of intersection. There's that one over there and there's that one over here. And we already know that this one's coordinates are 1 and 0. When we were finding x-intercepts, we discovered that. But also just looking at it visually, it doesn't make sense for x is equal to 1 to be on this side, because this is the negative side of the x-axis. So it makes sense that the negative 2 would belong to E. So now we know its x-coordinate. How do you think we can find its y-coordinate? So because it's a point of intersection between the two, it shouldn't matter which of the equations you put the negative 2 into to find the output or the y-coordinate. And in fact, that's a good way to test whether you found your point of intersection correctly. The output should be the same, whether you put it into the parabola or into the straight line. So let's put it into the straight line. We would have y is equal to minus 2 minus 1. So when my input is minus 2, my output is minus 3, sorry. Right, and let's test it by putting it into the parabola as well. So when my input is minus 2, so I'm going to say minus 2 squared plus 1. So that's going to be minus 2 squared is positive 4. So this minus is going to make it a negative all over again. And then we're going to have negative 3. So the output is the same for both of them, which is good. That confirms that our points of intersection are correct. So those are our workings to find the coordinates of A, B, C, D, and E. Okay, and then you're asked to find the distance AB. And because A and B are vertically aligned, they're both on the y-axis, we can find the length AB by subtracting the y-coordinate of B from the y-coordinate of A. So we know that the coordinates of A are 0 and 1, and the coordinates of B are 0 and minus 1. So the distance AB, or the length AB, is going to be the y-coordinate of A minus the y-coordinate of B, and that would be 1 minus 1, which is just equal to 2. And indeed, I mean, if you go from B to A, you go up 1 unit and then up another unit, and so that's a distance of 2. Cool. So we've done that. Then the distance GH, if the distance OF is 3 units. So the distance OF being 3 units is useful because that tells us the coordinates of F are -3 and 0. And this perpendicular, this information over here is important because it tells us that all the points on this line are vertically aligned. So that means that they all share an x coordinate in common. So G is going to be -3 and something, and H is also going to be -3 and something because they're all vertically aligned. And because G is on the straight line, that means we can use the straight line function to figure out the y coordinate. So basically we're asking ourselves, when my input is -3, what's my output? So y is equal to -3 minus 1, which is -4. So -4. And then h is on the parabola, which means we can use the parabola function to figure out what the y coordinate of h is. So we're asking ourselves, when my input is -3, what is my output, right? And if you work that out, you should get -8, right? And so now that we know the y coordinate of G and the y coordinate of H, we can work out the distance GH, because GH is just going to be equal to, again, the y coordinate of G minus the y coordinate of H. So that would be -4 minus -8, which is -4 plus 8, which is 4 units. And that makes sense. There is a difference of 4 between. Right? So we've done that now. And then the next thing we're asked to figure out is the coordinates of J and K if the distance JK is 4 units. So let's just tidy up. Right, so we're told that JK is 4 units long, and again, that perpendicular sign is there to tell us that these guys are vertically aligned. They have an x coordinate in common. Right, so in order to work this out, it's important that we go back to a fact that we've used for the past 2 questions. JK is going to be equal to the y coordinate of J minus the y coordinate of K. And so since we don't know what the x coordinate is, let's call it A, right? So we don't know what it is, we're just going to give it a variable name, right? And because these guys are vertically aligned, we know that if this guy's x coordinate is A, this guy's x coordinate is also going to be A. Now, how did we work out the y coordinates of these points? Well, if A is my input, then this y coordinate is going to be the output when A is the input, right? So because J lies on the straight line, that means that the y coordinate is going to be A minus 1, right? My input to the straight line function is going to be A, and the output is A minus 1. Then secondly, to find the y coordinate of K, K lies on the parabola. So I'm going to find what is the output of the parabola, the quadratic function, when my input is A. So the output is going to be y is equal to minus a squared plus 1, right? That's what my output is when my input is A. So minus a squared plus 1, right? And so to find this distance, we subtract the y coordinate of J, we subtract the y coordinate of K from the y coordinate of J. So y coordinate of J minus y coordinate of K, like we did for the past 2 questions. And so JK is equal to A minus 1 minus a squared plus 1. And we know that JK is 4 units, so 4 is equal to a minus 1 minus, minus a minus becomes a plus, and then minus a plus becomes a minus. So 4 is equal to a squared plus a minus 2. Again, quadratic function, to get one side to be 0, we're going to minus 4 from both sides. So then we have a squared plus a minus 6 is equal to 0. And that trinomial factorizes to a minus 2 times a plus 3 is equal to 0, which means that a is either equal to 0, a is either equal to 2, or a is equal to negative 3. And because we can see that j and k are on the positive side of the x-axis, it means that this is not a possibility, this is not a solution, because a is positive, a is bigger than 0, so a can't be equal to negative 3. So that means our solution is that a is equal to 2. And so in order to find the coordinates, so a is equal to 2, just going to replace it there. So to find the y coordinates, we're just going to substitute 2 everywhere we see an a. So this guy is going to be 2 minus 1, which is equal to 1. Right? And then this guy is going to be minus 2 squared plus 1, so minus 4 plus 1, which is minus 3. And those would be the two coordinates. So the coordinates of j would be 2 and 1, and the coordinates of k would be 2 and minus 3. And indeed, the distance between this point and this point, if you count 1, oh dear, 1, 2, 3, and another 1, that is 4 units. Cool. And then the last kind of question you can expect to see is this guy over here. The parabola is reflected in the x-axis. Find its new equation. So we're going from a parabola that looks like that, and we've said that, you know, its turning point is happening over here, and it's being reflected in the x-axis, meaning that this little guy is going to come down over here, and these little legs are going to go over there, right? So let's just draw that a bit more neatly. So the parabola ends up looking something like this, and we know that this then has to be minus 1 as a mirror reflection. So also then the steepness of the graph is exactly the same as you know, the original one, other than it being positive now. So so the equation is going to be y is equal to, instead of being negative x squared, it's going to be positive x squared, and it's a parabola that has moved down 1 unit, so it's going to be y is equal to x squared minus 1. That would be the new equation of the parabola. Let's look at another example. So the question's chopped off a bit there at the top, but it says sketched are the graphs of y is equal to f of x is equal to x over 4, and y is equal to g of x is equal to 4 over x. So that's what it says over there. It says 4 over x. No, I'm just demolishing everything. All right. Okay, I hope that makes sense. And then you're told that CD and EF are parallel to the y-axis. So CD and EF are parallel to the y-axis. And this is similar to how in the previous example you were told that a line segment was perpendicular to the x-axis. It serves to inform you that C and D are vertically aligned. E and F are vertically aligned. They share an x-coordinate in common. Right. And so again, this time they have not. Okay, they haven't matched the graphs for you, so you need to decide which graph belongs to which function. And f of x, which is x over 4, I hope you realize that that is the same as a quarter of x, which means it's just a straight line. So your straight line is f, while your hyperbola is g, the 4 over x. Righties. And even if you hadn't seen the x over 4 trick, you could have seen it by process of elimination. 4 over x is so very clearly the hyperbola because my x is in the denominator. The moment my x is dividing, then we know we're talking about a hyperbola. Cool. So let's see. First question. Determine the coordinates of A and B, the points of intersection of the two graphs. So remember, to find points of intersection, we're saying output of function 1 needs to be equal to output of function 2. So output of function 1 needs to be equal to output of function 2. So we're dealing with an equation that involves fractions. Get it over a common denominator. So in this case, my common denominator is going to be 4x. So I need something over 4x on this side, something over 4x on this other side. So that means I'm going to need to times by x over here. And over here, I'm going to need to times by 4 over 4. So then I end up with x squared is equal to 16, basically, right? Because once my denominators are the same, I can just look at my numerators now. Don't fall into the trap of saying, well, then x is equal to 4, because that's only going to give you one solution. And as you can see, these graphs are intersecting twice. So we're expecting two solutions. So it's a quadratic function. You're safest solving it like a quadratic. So x squared minus 16 is equal to 0. Difference of two squares. And so either x minus 4 is equal to 0 or x plus 4 is equal to 0. And so x is equal to 4 or x is equal to negative 4. Right? So that gives us, so this one will obviously then be the positive one. And this one will be the negative one. And then we need to figure out the y coordinates. And again, should be the same whichever function you plug them into. And so if you're to choose, let's say for example, then the question we're asking ourselves is, when my input is 4, what is my output? And that would be 1. So the output there would be 1. And when my input is negative 4, what is my output? And that would be negative 1. So this y coordinate over here would be negative 1. So those are your 2 points of intersection. Right. Calculate CD, right? And you're told that CD is equal to the output of F when my input is negative 2. So that's what this means, right? Minus the output of G when my input is negative 2. So basically what we're saying is that C and D both have an x-coordinate of negative 2 because they're vertically aligned. And as we said, the straight line is the function f. So the coordinates of C, let me just get rid of some clutter here. Right, so the coordinates of C would be negative 2 and whatever the output is when function f acts on an input of negative 2. And the coordinates of D are also going to be negative 2 and the output of G when the input is negative 2. So that's what this statement means now, that in order to find this distance, I'm going to say this y coordinate, which is the output when my input is negative 2, minus this y coordinate, which is the output of G when my input is negative 2. So like we did in the previous example. So basically the y coordinate of C minus the y coordinate of D. That's what that statement is saying. Right? And so we need to figure out what those two y coordinates are. So what is the value of the function f when my input is -2? Well, so f of -2 is going to be -2 over 4, right? My input is -2, and that is -1/2. And the output of g when my input is -2 is 4 over -2, which is -2. And so the length CD is going to be the y coordinate of C, which is -1/2, minus the y coordinate of D, so -2, and that ends up being 1.5 units. Right. Okay, next question says calculate the value of x if it is given that, okay, I think that is supposed to be calculate the value of k. Right, calculate the value of k if it is given that EF, so this guy over here, is equal to the output of G when my input is k minus the output of F when my input is k. So basically what we're saying is that E and F both have coordinates k something, right? And to find this distance EF, I need to find the y coordinate of E minus the y coordinate of F. That's going to give me the distance EF. And the y coordinate of E is whatever G spits out when my input is k. And the y coordinate of F is whatever the function f spits out when my input is k, right? Because remember, f is the straight line, g is the hyperbola, right? So that's equal to EF. So that's where this is coming from. Well, that part particularly. And we're told that this distance is 3 over 2. It's 1.5. So what's left for us is to figure out what g of k is and what f of k is. So g of k, when my input is k, the output of g is going to be 4 over k. And f of k, so when my input is k to this function, my output is going to be k over 4. So we're going to try to get everyone over the same denominator. My common denominator here would be 4k. So this guy I need to times with 4 over 4, this one by k over k, and this one by 2k over 2k. So we're going to have 16 minus k squared over 4k is equal to 6k over 2k. Nope, 4k, sorry. Right, and so since denominators are the same now, we can just look at the numerators. So 16 minus k squared is equal to 6k. This is a quadratic, so get one side to be 0. I'm going to move these guys to the right so that I have a positive k squared that I'm working with. And so I've got k squared plus 6k minus 16 is equal to 0. Right? And then we can factorize that. That is k minus 2 times k plus 8 is equal to 0. So either k is equal to 2 or k is equal to minus 8. But because k is on this side of the x-axis, not on the negative side, then we know that k must be 2. K can't be minus 8 because k is positive. Right, so we've worked out that the value of k would be 2. Right, next question is calculate with the aid of the sketch graph the solution of the inequality x over 4 is bigger than 4 over x. So basically, when is the function f producing bigger output than the function g? Right, that's the question we're asking ourselves, and maybe it will be useful to color code them. So we're going to call that G, and we're going to call this guy F. So for example, if we're to pick an input over here, in this case, G is producing a bigger output than F, because F's output is all the way down there. And so that means that in that case, 4 over x is bigger than x over 4, which is not what we want. Say we pick a different input. Let's say we pick this guy as our input. Then F is producing an output that's only over there. Meanwhile, G's output is over there. So G's output is bigger, which means that for that input, 4 over x is bigger than x over 4. So we don't want that either. That's not what we're looking for. So we're looking basically for a place where the straight line is above the hyperbola, because then we know that at that point, for those inputs, x over 4 has a bigger output than 4 over x. So for example, for this input, 4 over x is only over there, but x over 4 is over there, which means that for that input, x over 4 is bigger than 4 over x, which is what we're looking for. So obviously, we don't want to find these inputs one by one. We want to talk about them in regions. And so when you need to answer a question like this, the key points that you're looking at are the points of intersection between these two graphs, because it is when they intersect that they switch around, right? So if you look before this point of intersection, for any input that you choose this side, the hyperbola was producing higher outputs than the straight line, right? And then if you look in this region, so if you stop just before the next point of intersection, you'll see that for the most part, the straight line is producing higher outputs than, no. Yeah, okay, we need to modify that. So the straight line is producing the bigger output, and then the asymptote happens, and then all of a sudden things have switched around again. So if we look at these inputs, when we put them into the straight line function, the outputs are smaller than when we put them into the hyperbola. So we're looking for regions where the straight line is above the hyperbola, and that occurs in two places. So the places where F is bigger than G, or the straight line is above the hyperbola, is over here, and it's over here. And the key to knowing what is this x value, what is that x value, well, that's the points of intersection will tell us that. Right, and remember that our points of intersection were at -4 and -1, and this one was 4 and 1. So that means that for any input value between -4 and 0, the straight line is going to produce bigger output than the hyperbola. And then also for any input value bigger than 4, the straight line again is going to produce bigger output than the hyperbola. So for all of those input values, x over 4 will be bigger than 4 over x. So how do we write that? You can write it in one of two ways. You can write it as an inequality. So for that first region, input values between -4 and 3 and 0. Sorry, I don't even know where 3 is coming from. Right? So then we'd say that x needs to be bigger than -4, but smaller than 0. And it's always important to think about whether you're including these boundaries. So let's see. When my input is -4, is the output of the straight line bigger than the output of the hyperbola? It's not, because that's where they intersect. So that means that at that point, their outputs are equal. So we do not want to include negative 4 then, because x over 4 is not bigger than 4 over x at that point for that input. The outputs are equal in that case. And then do we want to include 0? Right? We can't include 0 because 4 over x is not defined. It doesn't have a value for when the input is 0. That's why it's an asymptote. So we can't include 0 either, because we can't say whether x over 4 is bigger than 4 over x at that point, because 4 over x doesn't have a value at that point. Right, so x is between negative 4 and 0, but not including negative 4 and 0. And then the other region we want to describe is this guy over here. So when my input is bigger than 4, so x needs to be bigger than 4. And again, we need to think about, do I include 4 or not? We're not going to include 4 because when my input is 4, the output of both functions, again, is equal. And we're looking for input values that make these outputs different. So x over 4 needs to be bigger than 4 over x. It can't be equal to it. So we're not going to include 4. So that's the one way you can write it. The other way you can write it is in interval notation. So you can say that x needs to be an element of the following interval. So from negative 4, but not including negative 4, up to 0. Or, okay, and we signify that with the union sign, it must be in the interval from 4 up until positive infinity. So whichever notation you're more comfortable with, use that. Cool. One more question. It says the hyperbola is reflected in the x-axis and moved up 3 units. Determine its new equation. So this is the hyperbola as we currently have it. And then it gets reflected in the x-axis. So this guy is going to come up here, right? And that guy is going to come down here, right? So that's the reflection. And then it gets moved up by 3 units. So the asymptote is no longer going to be over here. It's going to move up by 3 units. So let's temporarily displace those guys. So the new horizontal asymptote is going to be there, and then your hyperbola is going to be looking like that. And so in terms of steepness, once again, the steepness is still going to be the same as before, except there's now a negative aspect to it as well, because your hyperbolas are now living here and no longer living here. Right, so our equation is going to be y is equal to negative 4 over x, and then it moved up by 3 units, so that would be plus 3. Okay. Okay, so this is a good one to do for practice if you feel like you've followed the last 2 examples and you want to give questions like those a go by yourself. So feel free to pause before I walk through a question. Do the question yourself and then check yourself against my answers. Right. So the diagram below shows the graphs of f of x is equal to 3x squared minus 12, g of x is equal to 3x minus 6, and h of x is equal to minus 3x plus 6. The graphs of f, g, and h share a common x-intercept at D. The graph of f and g, the graphs of f and g, intersect at D and f. The diagram is not drawn to scale. Cool. So put your rulers away. Righties, and these ones have been very kind and decided to label the graphs for you. Cool. I'm just going to start by showing myself where the y and x axes are. Right. Determine the length of AB and CD. So AB, what we'll see about A and B is that they're both y-intercepts, the y-intercepts of our graphs. And, you should be able to see from the equations, if you look at f of x is equal to 3x squared minus 12, that's a parabola that's been steepened a bit and then moved down by 12 units. So that means that this y-intercept is now going to be 0 and minus 12 and not the origin anymore. And then A is the graph of y is equal to 3x minus 6, meaning that the y-intercept is at minus 6 as well. So this is a straight line that has also been steepened and then moved down by 6 units. So we can see from there that the y-intercept would be 0 and minus 6. So in order to work out the length of AB, we're going to say the y-coordinate of A minus the y-coordinate of B, so that's going to be minus 6 minus minus 12, which is equal to 6 units. And you should be able to confirm visually that, that works out with our numbers. To go from B to A, oh dear, I would just need to climb 6 units. Cool, so we now know the length of AB. And then C and D are the x-intercepts of our parabola. So what we're working out is, we know that x-intercepts have a y-coordinate of 0. Right, so what we're asking ourselves is, for which input is my function going to give me an output of 0? And this is a quadratic equation, so solve it like one. Factor out common 3, and then x minus 2 times x plus 2 is equal to 0. So that means that either x minus 2 must be 0 or x plus 2 must be 0. And so then x is equal to 2 or x is equal to negative 2. And so this guy would be the negative 2 guy, this guy would be the positive 2 guy. And so to work out the distance between C and D, that would be the x-coordinate of D minus the x-coordinate of C. So 2 minus minus 2, which is 2 plus 2, which gives us 4. Righty-os. Okay, next question. Oh, I just erased my point. Okay, the next question asks us to work out the length of OE and EF. Okay, so the special thing about E is that it's vertically aligned with F, and we know this because of the perpendicular sign. So if we can find F, which we can find because F is the point of intersection between my parabola and the function G. So remember, to find points of intersection, we're just going to say the output of function 1 needs to be equal to the output of function 2. So that would be 3x squared minus 12. Okay, no, I'm just rewriting the same line. So let's move everything to one side. So we're going to have 3x squared minus 3x. That's not going to miraculously become a plus. That will still be minus 6 is equal to 0. Right, so that's if I've subtracted 3x from both sides and added 6 to both sides. Factor out a common 3, so we're going to have x squared minus x minus 2 is equal to 0, and that would be 3 times x minus 2 times x plus 1 is equal to 0, which would mean that either x minus 2 is 0 or x plus 1 is 0. So x is equal to 2 or x is equal to negative 1. And we already have the x is equal to 2, 1. So, and also this f is on the negative side of the x-axis. So it's going to have an x-coordinate of negative 1. And then we need to find the y-coordinate by subbing into either function. And if you do that, let's say that we put it into the straight line function, we would have 3 times negative 1 minus 6, which gives us negative 9, and should be the same if you put it into the quadratic. So this guy is going to be negative 9, although we didn't need that actually. All we were interested in was, oh, we didn't need that, never mind. So now we know that the coordinates of E are going to be minus 1, they're going to share an x coordinate in common, and because it's on the x-axis, then that's going to be 0, the y coordinate. And so OE is 1 unit then, right? OE is just 1 unit because it's 1 unit away from the origin. And EF is 9 units. There's a difference of 9 units between these two. 0 minus minus 9, if you want to go the calculation route. Righties. Next up, the length of GH if OG is equal to 3 units. Okay, so OG is 3 units. That tells us that G has x coordinate negative 3, and because it's on the x-axis, its y coordinate is 0. And because these are vertically aligned, G and H are vertically aligned, that means that its coordinates, well, its x coordinate is negative 3 as well. And it lies on the line G, right? It lies on this line. So that means we can use that to work out its y coordinate. Basically, we're asking ourselves, what is the value of the function g, or what is the output of the function g when my input is negative 3? And that would be 3 times negative 3 minus 6. And if you work that out, that comes to negative 15. Negative 9 minus 6 is negative 15. And so the length of GH would be 15 units. 0 minus minus 15, or you can think about, how many times would you have to climb to get from minus 15 level to 0 level. Righties. Okay, so that's done. Those are done. Next up, we have the length of OI. The length of OI, where is I? Okay, the length of OI, that was inadvertently illuminating. Okay, so OI, if IJ is 6 units, so this guy over here is 6 units. So because I and J are vertically aligned, we know then that, okay, well, we don't know what the x coordinate of I is, but we know that its y coordinate is 0 because it's on the x-axis. And so then, okay, let's think about J. We don't know its x coordinate either, but we know that it's 6 units down from I, which means that its y coordinate will be minus 6. And because it lies on the line H, the question we're asking ourselves is, we have an output here of minus 6. Which input produced it, right? So minus 3x plus 6 needs to give me an output of minus 6. So that would be minus 3x is equal to minus 12, and x is equal to 4. So the input is 4, and because I is vertically above J, then its x coordinate is also going to be 4. And the question was for us to find the length of OI, so the distance from the origin to this guy, and that would just be 4 units. Right, maybe let's clear up some things here. Right, and then we're asked to work out the length of KL if OR is 1 unit. So the length of KL if OR is 1 unit. So OR being 1 unit tells us that R has coordinates 1 and 0, and because R, K, and L are all vertically aligned, we then know that K has 1 as its x coordinate, and so does L, right? And so then to figure out the length of KL, we need to figure out the y coordinate of this guy and the y coordinate of that guy. And because L is on the parabola, we can use the parabola equation to work that out. So that would be 3 times 1 squared minus 12. That gives you minus 9. And then K lies on the line G. So what is the output of the function when my input is 1? That would be minus 3. And so the line KL would have a length minus 3 minus 9, which is 6. That would be your answer there. Okay. Right. The next question asks us the length of ON if MP is 18 units. Okay, so MP is 18 units, right? And we need to figure out, basically we need to figure out the x coordinate of N, which is vertically aligned with M and P, right? And so we know how to do this now. We know that this guy, well, let's just say his x coordinate is A. Because he lies on the line G, the output when the input is A is going to be 3A minus 6. And this guy lies on the line minus 3 plus 6. Also has the same x coordinate, and the output of this function will be minus 3A plus 6. And so the length AMP will be 3A minus 6 minus 3A plus 6, and we know that that has to be equal to 18. So we have 3A minus 6 plus 3A minus 6 is equal to 18. So we've got 6A minus 12 is equal to 18, 6A is equal to 30, and A would be equal to 5. So that means that the coordinates of ON would be 5 and 0, because A has been found to be 5. And so ON would be 5 units long. Right, okay, that was a lot of distance calculating, but I hope you aced all of it. Right, and so the next thing that we're asked is, what are the values of x for which f of x is bigger than or equal to 0? So f of x, when is it producing positive values or 0 as output? And that's happening over here, right? Because all the way over here, all the outputs are negative, all your y coordinates are negative. So the question is, which input values are producing these output values, output values that are bigger than or equal to 0? That's what this question is asking, right? And so this is where it's useful to have our x-intercepts, right, which we found to be negative 2 and 0 and positive 2 and 0, because what this tells us is for any input smaller than negative 2, the outputs, so f of x is producing outputs that are bigger than or equal to 0. And for any input bigger than 2, the same is happening. My outputs are bigger than or equal to 0. And this is assuming that my parabola goes like this. My arrows are now losing the plot, but anyway, yeah, etc. So, so we would say that when x is smaller than minus 2, and again, let's pause to think about whether we include minus 2 or not. So when x is minus 2, when my input is minus 2, the output of my function is 0. And the question is, when is f of x producing output that is bigger than or equal to 0? So we can include minus 2. And then the other possibility is that we're looking at input values that are bigger than 2. And again, let's pause to think about whether we include 2. When my input is 2, the output of my function is 0. So we can include 2 as well over there, right? So that's the one way to write it. Or in interval notation, you would say x can be anything from negative infinity to negative 2, or from 2 to positive infinity. Oh, and we're including them, so round brackets are irrelevant over here. Right, so that would be square bracket to include negative 2 and square bracket to include positive 2 as well. Right, and then the last question is, for which values of x will f of x be smaller than g of x? So we're looking for places where the parabola is producing smaller output than this straight line. So let's see how the parabola is behaving. So all along here, the parabola is producing larger output than the straight line, because, you know, there's the straight line's output straggling over there. But then this intersection happens, and then the switchover occurs. Now my straight line is producing larger output than my parabola, which is what we're looking for. We're looking for places where my parabola has smaller output than that straight line. And then this intersection occurs, and a switch happens again. So now my parabola is back to producing larger output than my straight line, right? Because if I pick any input here, the output on the straight line is smaller than the output on the parabola. So basically my areas of interest are over here between, I'm lying, between these two. So from this point of intersection up to the next point of intersection. And right, so this point of intersection we found to be -1 and -9. So that means from when my input is -1 up until we found this to be +2. So when my input is between -1 and +2, then the output of my straight line function g is higher than the output of my parabola f. And then let's think about whether to include these boundaries. So when my input is -1, these functions both produce the same output. And likewise, when my input is 2, they both have the same output. And we're not interested in them being equal. We're not interested in their outputs being equal. We need g to be strictly bigger than f. So we're not going to include the boundaries. So that would be my answer. X has to be something bigger than -1, but also smaller than 2. In interval notation, that would be x is between -1 and 2, and we're not including the boundaries.